Okay, back to the fuel setup video that I was just making. We created the the additional calibration file that has the fuel part throttle and the fuel full throttle names switched, so we could match the fuel above 5 or 6 psi in part throttle to that of the fuel full throttle table. Okay, you can see the fuel part throttle table right here. Okay, you can see the fuel full throttle table right here, but you can also see them mirrored in the background because we used the comparison calibration that had the names swapped. Okay, now I'm going to change. Now, if you've used decal before, you've seen this area that says mouse. It is showing me what points I am at. Okay, this right here is your injector pulse width. This right here is your map PSI pressure. Since this is a 3-bar cal, it goes the whole way up to 29.4 PSI. From negative 14.7 PSI, or 30 inches of vacuum, to right about here is our 0 point. Okay, right. This is the boost side. Okay, I want right around 5, or I'll use this point actually right here, right around 6 or so PSI. I'm going to move this up to the line in the background that is actually a representation of the full throttle table. Okay, and I'll use page down to get to the last point because I need to drop this back down, and I just hold my down arrow. You can see the line slowly coming back down. I use the down arrow to get back down to that. Now, I'm doing this because, as I explained before, if you're using a Granger valve, your computer doesn't know to switch to a lower boost that's safe when you're at part throttle if you're using a manual boost controller. Okay, and now we have the same fuel curve roughly as the full throttle table. Let me give it just a little bit more right there, and so I don't have that little dip. Okay, it's essentially the same curve as the full throttle table from about 5 psi on up. That is a little sharp. Let me slope that just a little bit. Okay, there we go. That's a little smoother. So that's the one tweak I like to do. And then full throttle right there. Let's save this. Okay, as our Turbinator LM cal. And okay, reload it. I don't want to see that in the background right now. It gets a little confusing. Full fuel part throttle, and if you hit the fuel full throttle, you can see that you got about the same amount of fuel up there. Okay. Okay. Fuel no throttle is also a table that we have to do the last point trick to. Let's see. Did I do that to the? I did it to the fuel part throttle table, obviously, because I moved the lines all around. Fuel full throttle. Let's move it up till we see a move, and right back down again. And then the fuel no throttle table. Last point. And right there the line moved, and right back down. Okay, the other table we need to talk about is the pumping efficiency table. Did I describe these tables well enough? I'll do a once-over on what these fuel pressure tables do. Let's just say fuel full throttle. These tables take into account their calculated table. They're calculated based on your engine size and your injector's pulse width and your air pressure or vacuum. Your injector size, your engine size, and they assume that 100% of the cylinder, in this case we were using a 2.5 liter based cal, they're assuming that 2.5 liters of air at 0, or even 2.5 liters of pressurized air are filling the cylinders, and this table calculates how long the injector pulse width should be to provide enough fuel for a calculated air-fuel ratio. They need another table to take into account the increases in efficiency or decreases of efficiency based on RPM. That's what this table does. Okay? So if everything were perfect and 100% of air made it through the cylinder head and out the exhaust and whatnot, this table would be a flat line at 1.0 or representative of 100%. But that's not how it is. 100% of 2.5 liters of air does not make it into the engine through the cylinder head and through the intake manifold. So you need a table based on RPM that accounts for those variations. Camshaft tuning, that also plays a factor in how much air gets into an engine at a certain RPM. The plenum size in your intake manifold, the cylinder head porting, the exhaust manifold porting, or a different style of exhaust manifold, or your turbine housing, like a 0.48 is obviously more restrictive than a 0.63. That is corrected with using this table. Your exhaust housing, your O2 housing, your swing valve housing, how much that flows is taken into account. Anything that affects the airflow through the motor, your intake piping, your exhaust system, your mufflers, that all is corrected using this table. Now, initially we don't have to do anything unless you're building a new motor that already has a ported cylinder head on it. Say we have a ported cylinder head on this here, on a motor, on a 2.5 liter motor, let's say a stock Garrett turbo, whatnot. You're going to be flowing a little more air in the upper RPMs especially. So right from the get-go, you should probably raise from here onward up a little bit, let's just say, just for kicks. You'll have to adjust this later, but let's just say, let's adjust this up a little bit, okay, to account for the additional airflow that the motor is going to be able to have with a ported cylinder head. Okay, now when you take this out to do your initial pulls or on the street or whatnot, you're going to use your wideband, and you're going to use your wideband, and you're going to use your hopefully a data logs or some kind of data logging. Use either a scanner or in a logic module case, you could use one of those TTL to serial adapters, and you on your laptop, and use Jeff Chinaki's LM log program, and you're going to data log as you drive at full throttle. You're going to set your boost as low as possible for safety, and data log using boost and RPM. You will want, and your air fuel ratio. You'll want to know what what RPM areas are rich or lean, and that's going to be tuned with this table. That's how this table works. Okay, so we've covered the error that you need to correct with this last point based on improper scaling from the SMEC injector scaling function. How to make your part throttle fueling higher in above 5 psi, and how the pumping efficiency table works. That should be it for this installment. Oh, one more thing. I almost forgot. You see how high these graphs are for your these fueling tables? Actually, let me hit save first before I forget. Okay, let me open up another instance of decal. Oh, I got a phone call. I gotta go. I'll cover that in my next video.